Hey everyone, it's Justin again. In this lesson, we're going to be taking equations in two variables and rewriting them as functions in only one variable. These examples will be helpful guides on the practice game and assessment, so don't forget to take notes. We want to write this as a function of x. In other words, x is going to be the input while y is the output, or the function. So we need to isolate y on one side with x and everything else on the other side of the equation. So let's move both x's to the right side by subtracting 3x from both sides, and then get the y's on the left by subtracting 9y. Finally, we want the y isolated, so let's divide the -5 from it. And there we go. But wait a second, this still isn't a function. Remember, we're treating y as the output here, so we turn it into function of x. Notice that as a function, there's now only one variable, x, which we plug in, and then the math will automatically create an output tied to that input. No, this isn't the same problem as the last one. Can you spot the difference? This time, we're going to write it as a function of y. It's going to look a little weird because this time we're going to be treating y as the input and x as the function's output. The process, though, is going to look almost exactly the same. Our goal is to isolate the output, but this time it's x. So let's add 3x to move the output to the left side, subtract 4y to move the input to the right side, and then isolate the output by dividing by 6. Now that we've got the output set equal to an expression of the input, we can transform the left side from x to function of y. One thing you might notice is that this answer is very similar to the previous answer. Not only did the input swap, but the fraction being multiplied got flipped. These are known as inverse functions, and we're going to be focusing on inverses a little later in this unit. But for now, let's keep going with the examples. Functions can be written based on any variable, like this one that we'll write in terms of c. For this function, c is going to be the input and m will be the output. So our goal is to isolate that output, m. First, those parentheses are locking away several pieces of the equation, so we're going to need to distribute the -2. And now that the parentheses are gone, we can isolate m by adding 4 to both sides. The only thing left to do now is rewrite the unneeded variable m as a function of c. All right, final example. We're using the same equation here, but this time we're writing it as a function of m, so we need to isolate c. First, let's distribute to get rid of the parentheses. Since c and m are already on different sides, we're going to leave them where they are for now. We can flip it around so c is on the left side at the very end. So next, we're going to subtract 6 to move it to the side with the input variable, and then divide everything by -2. Be careful with signs here. 1 divided by -2 is -1/2, and -10 divided by -2 is +5. Now that the c is isolated, we can flip the equation over, so c is on the left side, and then we rewrite c as the function of m. Make sure to test out your skills in our practice game. In the next lesson, we're going to be applying what we now know about functions by graphing them. See you then.